Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. I am sorry, I think I need to redo back this video due to several correction that I want to highlight during our previous class, okay, today class. Okay, so this is a circuit theory SEEU 1023. So this is actually the slide that where we will introduce you what is electrical circuits and methods analysis that can be used to analyze electrical circuit. So in general, what is a circuit? So as you can see here, is the circuit is actually an interconnection of several electrical elements such as resistor, capacitors, and inductors. So the combination of this is actually called a electrical circuit, and it is used, for example, to convert for example, this application is actually for the radio application where we have a frequency wave signal here from antenna and then converted due to using or via the electrical circuits into an audio signals. And in general, okay, in electrical circuits, we are dealing with two type of what we call source. Okay, we have the DC source and also AC source. And if the circuits is actually connected to the DC source, so that circuit we call a DC circuits. While when it is connected to AC source, we call it as a AC circuit. So what is the difference between DC and AC? So DC is actually the short acronym for the direct current. So as you can see here, the figure here, figure A, this is showing a current that is actually have a constant value throughout the time. So it is actually independent of the time. So this is what we call a DC current. Okay, and the common source for the DC current is for example, a battery. Another one is actually AC circuit. Okay, so this one is actually referring to the what we call alternating current, such as this figure B. As you can see, it is must be in a sinusoidal form. Okay, for electrical circuits, the AC system must be in sinusoidal form. Okay, and this sinusoidal form is actually varying, the magnitude is varying with the time. Okay, and the example of power supply is actually our AC power system that supply in through our house. Okay, so that is the difference between DC and AC. Okay, let's go on the power. Okay, so in electrical system or electrical circuit, so the power is actually the product of the voltage and also current. So P is equal to VI and the unit is in watt. Okay, so what is power? So power is actually equal to the rate of energy provided or consumed per unit of time. So we can use P is equal to work, or sorry, this one should be divided, okay, divided by time. So P is equal to work over time, okay, and the unit is actually in joule per second, okay, joule per second. So in electrical circuit, we always refer the power in unit of watt, okay. And for electrical circuit, there are two categories of power. So we have different sign. So we have the positive sign and we have a negative sign. So positive power and negative power. What is mean by positive and negative? So if you have positive P, meaning that the power is actually absorbed by the element. Okay, and if you got the P is negative, meaning that the power is supplying by the element. Okay, so meaning that in this circuit, we have elements that absorb and we have also element that can generate power. So to determine whether this element can uh, absorb or generate, which element can absorb, which element is actually generating the power. So we always use what we call the passive sign convention. Okay, so to determine whether positive and negative, always refer to the direction of the current. So if the direction of the current is entering the positive terminal of this element voltage polarity, so the sign is a positive, meaning that this element is actually absorbing. Okay, and if the current is going out from the positive terminal, or in other words, is going into the negative terminal, so we will have a negative P. So this one we call, this element is actually generating the power. So this is where this passive sign convention is used. Okay. And passive power convention. So this one is actually a law, or what you call uh, I think we can call it as a law. So the sum of power inside a circuit must equal to 0, meaning that the summation of all elements absorbing or generating must all equal to 0. Okay, so these equations are valid regardless of any electrical connection. For example, if I have this element, okay, a voltage source, and then we have a resistor here. Okay, so the current is going in this direction. So this one positive polarity for the voltage source, and this one is a negative the polarity of the resistor, for example. Okay, so since this one is actually going out from the positive terminal of the voltage, so this voltage source is actually a negative P. Okay, element number one, negative P. And as you can see right now, for this resistor, the power is the current is entering the positive terminal of the element. So meaning that this resistor is absorbing the power. So based on this passive power convention, it says that the summation of all powers of the element inside a circuit must equal to 0, is that negative P1 plus P2 must is equal to 0, or we can conclude that, or we can deduce that the power, all the power generated by the source is absorbed by this resistor. Okay, so if I have, for example, if I have another elements, for example, I have two resistor. Okay, so since all the current is entering the positive of the resistor, so this one will become positive P1, and this one also positive P2. So the summation of power, negative P1 plus, sorry, this one P2, this one is P3. Okay, sorry, P2 plus P3 must equal to 0, or I can also write down as a P1 is equals to P2 plus P3, meaning that the power generated by the source will be absorbing by resistor R2 and also resistor R3. Okay, so if I have like this, for example, a circuit, I think I need to erase all this. Okay, a voltage source, okay, and a resistor R2, R3, for example, and then this is my V1. So this one will become negative P1, and this one positive P2, and then this one is positive P3. So same. So you will write down the power equation, negative P1 plus P2 plus P3 is equal to 0, or I can write down as a P2 plus P3. So it's actually, regardless of any connections, the power should be sum out equal to 0. Okay. Okay, so this is the example from your textbook. Okay, so P1, so 60 watts. Okay, and then P2 is not given. You need to find it. And P3 is negative 145 watts. Okay, and P4 is 75 watt. So based on the passive power convention, so how many watt does element to absorb? So just use the summation. So 60 plus 75 minus 145, so is plus P2, so it's equal to 0. So your P2 should be 145 minus 60 minus 75. So your P2 absorb around maybe 145 minus 60 minus 75. So this is actually 10 watt. Okay. So the conservation of energy, so this is related to the conservation of the power. So energy cannot be created or destroyed. Okay, so meaning that the power also must be conserved. So all the summation of all power supplied must be equals to the power absorbed by other elements. Okay, and the energy, which is the unit is joule, is actually not similar to the power. Okay, the energy is actually watts multiplied with times, and the unit is joule. And usually for our bills, electrical bills, they are not charged on the power watt, okay, but it is charged based on the energy. So in electrical system, the energy is joule. Okay, sorry, in general, the energy is joules, but in electricals, it is better to use watt hour, or sometimes kilowatt hour. So this is actually referring to energy. So the electric power utility companies in Malaysia, we have a TNB. So they will measure, they will charge you based on the energy usage, not power. Okay. So 1 watt hour is equivalent to 3,600 joules. So how can I got this one? So we know that for 1 hour, so you need to convert this hour into seconds. So 1 hour we have around 3,600 seconds. Okay, so and then multiply with 1 joule over second, so you will have these values, 3,600 joules. And please be noted that 1 watt is equal to 1 joules per second. So right now, the next example, how much energy does a 100 watt electric bulb consume in 2 hours? Okay, so the electrical bulb is 100 watt, but right now, you want you to calculate how much the energy consumed by this electrical bulb in 2 hours. So it's very easy to obtain that. So W here is actually the energy used. You need to multiply, is equals to the power used multiplied with the time. Okay. So we have the rate of the electric bulb is 100 watts and the time used is 2 hours. But you need to convert the hours into seconds. Okay, so after you have converted this one, so multiply with 100, you will get 720 kilojoule. Okay, so this is in unit joule. But in electrical system, it is always preferable to just write down in watt hour or kilowatt hour. So just simply you multiply with the watt of the bulb, multiplied with the usage 2 hours. Okay, so 200 watt hours, or in other words, is actually 0.2 kilowatt hour. Okay, and this energy consumption it depends on the period of the duration. For example, if this electrical bulb is only used for 1 hours, so as you can see, the energy use is reduced. So 100 watt multiply with 1 hour. So this one just simply like 0.1 kilowatt hour. Okay, so meaning that to have less electrical bills, you need to have what you call to minimize the usage of your electrical system. So if you make the bulb to turn on, always turn on 24 hours, so definitely you will have a higher electrical bills. Okay, so this is another examples. This is from United States examples. So a homeowner consume about 700 kilowatt hour in January. So determine the electricity bills for the month using the following residential rate schedule. So we have this one, base monthly charge $12. So this one is actually a fixed charge. Whether he use or not use electrical, so it will be charged $12. And then for the first 100 kilowatt hour energy, it will be charged based on this rate. And for the next 200, this one, and over 300 is this one. Okay, so right now, the basic bills, so it will be charged $12. Okay, $12. And the next is the first 100 kilowatt hour. So 700 multiply minus 100. So the balance is another 600. Okay, so this one, we have 100. So you need to multiply with 60 cents. So it will be $16. Okay. And then from this 600, so you need to minus this next 200 kilowatts. So you have another balance 400 kilowatt hour. So for this 200, so you need to multiply with 10 cents. So this one will become $20. And this extra is 400 kilowatt hour is we'll use this rate. Okay, we'll use this rate. So for 300 kilowatt per month, so you need to multiply with 6 cents. So 400 multiply with 0.06. So this one will become $24. So you sum up all of this, you will have the total bills is $72. So every month it need to pay $72 per month. Okay, so I think we have finished on the power, on the general equations or the general definition, energy, power, and also circuits. So right now we are going deeper to the circuit elements. Okay, so there are two types in electrical circuit, the active and passive. So what is the active elements? The active element is actually the elements that can generate energy. For example, we have the power generator, okay, power generator, and then we have batteries and so on, okay. So these generators, meaning that, for example, we use oil, okay, we use what you call petrol to generate electricity. For example, at our night market and so on. So it use electrical generator there. Batteries is actually it's actually a battery, so where we charge the battery in a chemical form, and then based on the reaction of the chemical, it produce electricity. And the third one is the operational amplifiers. So this one is not related to this course, so but it's actually um, more towards on the transistors. Okay, how we can use transistors as our active elements generator. Okay, but for this circuit, we only concentrate on the batteries. Okay, as our active elements. And then the second one is the passive elements. So this is the elements that under passive. We will have a resistors and capacitors and also inductors. Okay, and the resistor is the only element that absorb the energy. Okay, while the capacitor and inductor, it can supply and it can absorb. Okay, so meaning that this capacitor inductor is actually uh, is actually can store the energy. It can charge the energy, and then at the same time it can also discharge the energy. So this capacitor and inductor, even though it looks like it can generate electricity, it can generate the energy, but it is actually just a storage element. It cannot generate the energy by themselves. So that's why we categorize these capacitors and inductors under passive element. So the either voltage source, I think I just skip this one. I think no need to further elaboration. So for voltage source, so this is the symbol, okay, and the polarity. So the voltage and the current will always go out from the positive terminal. So meaning that this energy, this voltage source is actually supplying the energy. While we have another source, which is a current source, okay. So the source is actually a current. So the current direction, meaning that the current will flow base is actually same with the direction of the current source direction, and the polarity of the voltage is like this. Okay. So the Ohm's law. So the Ohm's law is actually the very basic law for electrical engineering, where it states the voltage and current are proportional. Okay, when the voltage is increased, the current will also increase. This is actually referring to the element of the resistor. Okay, so if the current flow inside the resistor is increased, the voltage drop across this resistor will also increase. If the current flowing inside this resistor is reducing, so the voltage drop across the resistor will also reduce. And this relationship is actually can be V over I is we can relate using what we call a resistor R. The unit is ohm. Okay, so the voltage and I, the relationship is actually proportional. Okay, so to determine whether the voltage is positive or negative, it depends on the passive sign convention. So the passive sign convention stated that the current, to have a positive, the current must enter the element from the positive terminal. Okay, so if the current is entering the positive terminal, so you will have the voltage drop across the resistor is in positive value. Okay, and if the current is going uh, into the negative terminal, okay, the voltage drop across this resistor, you will have a negative sign. And this is the example. I think this one is a very simple example. So calculate the current when it is actually in uh, the first position. So the current direction is like this. Okay, and the polarity is this one. Okay, so the current is equals to V over R. Okay, so this one is actually 40 volts over the resistor 100 ohm. So this one is 0.4 ampere. Why the voltage? This voltage is actually the voltage across 100 ohm. Okay, so which is the same with the voltage source here. And when it is switched at this position, so the circuit will become like this. So 40 volts the voltage across the resistor is still 40 volt. Okay, it's same with the source. And the current, you can calculate the current. So I is equal to voltage across the resistor over the resistor. So 40 over 250. So you will obtain the value of 0.16. Okay. So this is the extreme case where your circuit can become short circuit and also open circuit. So what is the definition of the short circuit? Where, as you can see, if you have a circuit here inside this one and then connected to a load, okay, connected to a load, and then this load is suddenly short circuited where your resistor is zero. So the voltage across the resistor will also become zero. Okay, and then there will be a current flow here. Okay, and based on the circuit here, the current here may be very in high current. Okay, and then the next extreme case is where when your resistor is a very high values, and which is infinity. When this one is infinity, you will see that the current will actually become zero. Okay, so meaning that there will be no current flowing from this point to this point. And sometimes this voltage we call the voltage open circuit. Okay, so this is linearity. So in ideal case, if the circuits contain resistor, so the voltage and current will be always in a what I call a proportional form, a linear relationship. But in real world, where sometimes the circuits contains not only resistor, sometimes have a capacitance and also inductance. So the relationship between voltage and current will be in non-linear shape. And this is the conductance. So the conductance is actually the inverse of the resistance. Okay, the unit is the symbol is G, and the unit is MHO, which is you spell it from backward. Okay, and the unit is Siemens. So what is conductance? So this is the definition of conductance, the ability of an element to conduct electrical current. Okay, and then this is the power absorbed by the resistor. So you have two elements. You have this one, so the first one, and then you can also find out um, that the power can also be used like this one or the third one. So how to derive from this into the second one is just like V multiplied with I. So we know that we know that voltage is IR. So you just multiply with I. So that's why you have I square R. And then to get this one, so we know that V multiplied with I. So V multiply, we know that I is equal to V over R. So that's why you have V square over R. Okay, and nodes, branches, and loops. Okay, I think this one, for example, this circuit. Okay, so this circuit has, um, so what is the branch? So branch is actually represent a single element, such as a voltage source or a resistor. For example, if I have this circuit, okay, so this circuit, I can say it has 1, 2, 3 branch. Okay, 3 branch. And node. So node is the point of connection between 2 or more branches. So based on this circuit, I have only 1, 2. Okay, This one is not considered as a node because, as you can see, it's not a branch. Okay, it's not a branch because there is no element here. So we have only two nodes. And what about loops? So loop is actually any closed path in the circuit. So for example, in this case, we have only one loop. Okay, if you have a circuit like this, okay, so I can say that you have one branch, sorry, 1, 2, 3, and 4. So you have 4 branch. What about the nodes? So the node is 1, 2, okay, and 3. Okay, because it combine this branch, okay, it combine this one and this one. So you have 3 nodes. And what about the loops? We have 1 and 2. So this is loops. The other one that may be referring to the textbook, sometimes they also referring this one as a loop also. But I think this one is called a super loop because under this loop we have these 2 loops. So I think that one is not considered as a loop. It's a super loop. Okay. So you have for this circuit you have 2 loops. Okay, I think that's all, and then I think we will proceed with next videos next week. Okay, thank you very much.